My name is Gregory Macdonald. Right now, I'm bringing you a conversation between my good friend Ryan Boldi and I. Ryan is the smartest person that I have ever met. Now, I'm not exactly sure what that word smart really means, but I do know that Ryan and I met in mathematical philosophy class. This was a class where I was sitting there with frustration on my face, sweat dripping down my forehead that you could probably see a mile away. Every single telltale sign that you can think of, which said, I'm stressed because I don't understand, was showing. And Ryan came up to me after class one day and offered to help me out and gave me his number when I agreed. So we ended up going to the library and sat down with this everlastingly complicated material and made a regular occurrence out of it. We met 2 or 3 times a week, getting to know each other very well. But most of all, Ryan helped me understand that material so much that I ended up getting an A in the class. Now, Ryan didn't get an A in the class for me. It was Ryan's ability to simplify the material enough to help me have the capacity to get an A in the class. And if you ask me what makes somebody smart, I would tell you that they're able to take the most complicated material and distill it into the simplest terms that anybody can understand. Ryan is an excellent example of character. And in this conversation, we talk a lot about AI, as that's his specialty. He's at MIT right now. But we also go into exactly how he got where he is today, between relationships, goal setting, time management. There is infinite value in this conversation. And I believe that the same way he simplified the material for me in that class, he simplifies the material here in this conversation. And I really hope that you listen to what Ryan has to say. I also hope that you enjoy the time that you have with Ryan and I. Thank you so much. We will talk soon. Give me a second to introduce yourself here.
Yeah. So hi, everybody. Hi, Greg. Thank you for having me here. I'm Ryan Boldi. I'm undergrad at UMass Amherst. I'm a senior graduating now. I've been doing a lot of work in the area of artificial intelligence and research in general. I've been working in psychology and philosophy as well through my coursework, and I'm a computer science student besides that. Yeah.
So computer science, you work through AI, right? And you've done a lot of work. If you just take a look at your name online, there's actually 14 sites on Google Scholar, and some of them actually have 20 plus citations. And you're only an undergrad, and you're going to MIT for your PhD, and congratulations on that.
Thank you.
That's phenomenal. What is it that's got you got your mindset in this mode? Because that's a high achieving position to get to.
Yeah, I'm really fortunate about all the opportunities I've been given. And obviously, without the opportunities, I wouldn't be anywhere here. But I kind of got lucky and stumbled into finding the right thing at the right time. Like a lot of people when they join their undergrad, they don't really know what they want to do. And I was really lucky that I knew what I wanted to do super early, so I could just start directly working towards it. So I got fortunate in that sense, So in high school, I started working on this area called neuroevolution, which is the idea of trying to simulate the evolution of brains in a computer, and you can have them learn from simulating the evolution of them. And the reason, and it sounds way more complicated than it actually is, it was because I wanted to do machine learning work, which I'll talk about later, but I didn't know anything about the math behind the machine learning. And so it turns out that evolution, you don't have to do any of that math because it's like a really simple mechanism and it works really, really well, or at least I thought it did for those environments that I worked on. So I would build small games. I would it actually started with game development. Like I started building games and I was like, oh, what would make these games more interesting is if I had AI that played the games. And so you can compare your performance to like an optimal game player. So you can imagine like a little platformer game, right? Where you have like an agent bouncing from one place to another. You could build an AI that plays the game really well and you can compare your performance to that. So I first built the game and then I was like, all right, let me build an AI that does it. And the way it works is that you just randomly create like 1,000 neural networks or something that play the game. And at first they're all horrible, right? At first they just don't know what to do. All the agents like fall off the towers and just like go and instantly lose the game. And so what you do is you find the ones that do slightly better and then you take their neural networks that ran them and you make slight mutations to them. So you don't have to do any math at all. You just randomly change the numbers inside the neural network and then they get slightly better, right? And so, you make random mutations and then some of them are better, some of them are worse. And then you pick the ones that are better, right? You just like run them in the environment and then the ones that last for longer, you pick them again. And so this is called the evolutionary programming loop where you have a evolutionary population and then you evaluate them in your like world, and then you just like have them run in a loop, and then if they do well, you select them for reproduction, you make mutations of them, and then you put them back in the population. If they do badly, they don't get to do that. And so eventually the population gets better and better, and they start to play the game. So I would like go to sleep, wake up, and I would have agents playing the game perfectly on my computer when I woke up in the morning, which is like really weird to see that it was like these things were created overnight on my computer, like this intelligence. This is all in high school, by the way.
And that's the evolution process working in itself. And so what makes it so simple? What makes
the simplicity of it is that if we contrast it to machine learning right now, the way that machine learning works most of the time is that you build a model, and then you have to do some math on it to derive this thing called the gradient, or the derivative of the model. And what that is just like really a high dimensional process. It's really expensive to do. You basically have to invert the model to see how changes in the parameters will change the performance of the model. And that's expensive to do. And you have to do a lot of math to get it, or to understand it. It's pretty easy to do programmatically. It's like 3 lines of code, but you have to understand what's happening. And I didn't understand what was happening because I didn't learn linear algebra. I didn't learn multivariable calculus. So I didn't know how to do these kind of things. And so at the time, it was really easy to just take a random neural network, which is just a matrix of numbers. It's just like a set of a bunch of numbers from 0 to 1 or whatever. And then you just make random changes to those numbers by adding random noise to them, which is super easy to do. And then it's a for loop. You just run it like over and over again, which is also really easy to do. So it was like a bunch of easy things, and you never once have to know how a neural network works. You don't even need to understand them. You don't even need to know how backpropagation works. The thing I was talking about before about learning. You just run them, and then you make random changes. Then you run them, make random changes. And then they get better.
Yeah, that's awesome. You said you got into this through opportunities, and that's very interesting. The opportunities, do you think they come from, the outside world coming into you? But it seems like you're more driven into this world in a sense of you really want this, and because you really want this, maybe these opportunities have just come to you.
Yeah, I mean, I've always been interested in this stuff, and I always knew I was interested in it. And when you know what you're interested in, it's like the law of attraction or whatever. You know what things you're interested in. So any signal of that, you're constantly paying attention to it. So if you hear someone talking in the like 3 behind you talking about AI, you're like, oh, I'm interested in that. I'm going to go talk to them, for example. So I think opportunity does come at random, but if you are in the right mindset where you're looking for the kind of things that you're interested in, it's very easy to find them because they come to you. It's like almost like it's like attractive that when you have a thing that you're looking for, all the opportunities are attracted to you and they come towards you, and then you get them very easily.
Yeah. What interests you in this? What got you interested in this?
I was really always interested in learning and in the human brain and the mind, and like trying to figure out. At first, it was like the philosophical perspective of what is the mind and what is consciousness and what are all these things. And then I realized that philosophy doesn't really answer those questions satisfactorily for me. It's more like they have a bunch of people sitting there and thinking their whole lives about things, and they make a lot of really interesting conclusions, but I don't really feel like I was satisfied with the answer. So I turned to psychology and looking at the human brain and like looking at how the human brains learn and neurons and real things. And then at final, I was like, okay, that's really hard to do because the human brain is so complicated, and it's really hard to study the human brain. A lot of people do it on people that have like some kind of injury where one part of their brain doesn't work anymore, and then they can look at their behavior and see what's broken. But it's really, really difficult to do that because there's a limited amount of like random freak accidents that happen that let people do studies on. And I think that's also starting to get a bit immoral to do that kind of study. And
right.
So I think that the best way is like if you want to really understand something, you have to try to make it. And so the best way to understand the brain is to try to make it in a computer, right? And so that was like my intuition from the beginning, is that I was like, all right, so the goal is to learn about intelligence, and my way to learn about intelligence isn't philosophy, isn't psychology, but it is computer science. And then the philosophy and psychology help you in building the whole story through the computer science. Like it's grounded in philosophy and psychology, basically.
Yeah, because I hear a lot that computer science is really connected into the philosophy field.
Yeah.
And that's interesting because the philosophy, like philosophy of mind, for example, a lot of these papers and a lot of these academic works, there is no conclusion,
Mm-hmm.
and people kind of leave it up to that. But then the computer science, like you were talking about, the math has to be right and everything has to be right to create this evolution.
Mm-hmm.
And so clearly you doing that in high school had started this evolution,
Yeah.
And the other day we were sitting and you told me that, you had like a plush of an MIT like toy and when you were like 12 years old and you just knew that's where you wanted to go.
Yeah, I mean, I was always really interested in the people there. I think there was like a very big research community, so I was always following the community of research there, the kind of things that were being studied there. They have like in the history of AI, they're a very significant figure as well, and they were significant in the same lens of things that I'm interested in, which is the symbolic group of AI. So in the history of AI, there's like the symbolic group, and then there's the connectionist group, and most of the symbolic group is associated with MIT and the East Coast schools, and the connectionist groups are associated with like Berkeley and the West Coast schools. And the connectionist group right now are the things that are behind these like really, really big neural networks that are super, super expensive to run, and they train on a lot of data like ChatGPT, for example. Whereas the symbolic group is more about like good old-fashioned AI, like building symbolic systems that are really low level and emulate how the brain really works and things like that at different levels of explanation. So I was always drawn to that, and so I knew that I really liked that area, and also being from Boston, it was like always there, and so I liked it. So I'm glad to finally get to be a student there, and I'm just looking forward to it.
Yeah, that's great. So this learning process, the AI, clearly you've probably faced some failures in your learning with the AI, right? Can you describe maybe one of those times, and maybe, have you been driven off in a sense of, man, this MIT thing might not work out, or this AI might not work out?
Yeah, I mean, it's very difficult. The work when you get started in research in general, it's very, very difficult stuff. And especially being some freshman at UMass, like I don't have the mathematical background, as I said before. I didn't have the research background. I didn't know how to write a good paper, how to do all these things. And so when I first came to college, I was completely lost, right? But all I had was like this passion that I really wanted to work on this kind of thing. And I knew that I wanted to do research, and I didn't want to do some kind of software engineering role. I knew that I wanted to actually study questions that I could answer and try to do new things, instead of just writing code for someone else. So I started like emailing some professors, and one professor that I emailed, Lee Spector, was very gracious enough to take me in as a student, even though I knew nothing, right? And so he told me, he was like, here's this book about genetic programming. Seems like it's interesting. Genetic programming, I'll talk about it a lot probably, but I read that whole book when I was like, before I even came to college, and then I started doing research right from the get-go, attending meetings, and I was really bad for a long time. It took me easily like 6 or 7 months to really understand what was going on. And then after I started understanding what was going on, then I could start asking my own questions. Once I started figuring out, okay, here's where the knowledge of people is, and this is the kind of things people don't know yet, I could start figuring out, okay, what's the easiest possible experiment I could run to answer one of those questions that people don't know yet. And so I did like a really small experiment that was super simple, and it turned out to answer this question that people didn't really know about before, which is about, it's a really niche and really, really low-hanging fruit, which is about this idea of downsampling in genetic programming. So I'll give some background on genetic programming now. The idea is that the evolutionary loop that I was telling you about before, that's with like these little neural networks that run and play games, for example. Genetic programming, the agents that you're evolving are not neural networks, but they're computer programs. So it's kind of weird to think about. Like, it is a full computer program that is the thing you are creating. So for example, you might say, okay, what is the program to play this platformer game? Well, the program would be something like input the distance from the player to the next tile. If that distance is below 0.3, jump. If that distance is above 0.8, don't jump, right? Or something like that, right? Yeah. And you can just write this as a computer program instead of having to write it as a neural network that you don't understand at all. Like the neural network is just going to be a bunch of numbers that just multiply together to create the output, where you don't know how those numbers result in the output. But in genetic programming, you can read the code and you can see exactly what it's doing. You can say, oh, okay, so I can see this agent is jumping whenever the tile is close by. And then I can be I can feel much more safe about that agent, because I can look at that agent and say, okay, I know for sure that agent will hit every single tile. It'll never fall. But with the neural network, I can only watch it and see. And so that's kind of like the idea of psychology. Like, you can never be sure what a person is thinking. You can never be sure what a person will do, because you can't look inside their brain and understand it. But if your brain was written as a computer program, I could just read it and say, oh, okay, so when I say this, he's going to say this, so I can be sure that it's like you're like a safe person or something, right? Like, so that's the idea of genetic programming. It's just you're learning on a higher level. An interesting thing is that the programs in genetic programming, a neural network is a computer program. In fact, all the times that you write neural networks, you're writing them in code for a computer program. So this is a higher level explanation. It's a more general representation, as they say, which means that any solution you can represent in this program space. So you can represent computer programs, you can represent neural networks, you can represent every other machine learning paradigm in this program thing. So it's a much bigger search space that you're searching through. And as a result, you can solve a lot more cool problems from what I can tell. So I started reading about genetic programming. And the idea for downsampling is that to do evolution with a computer program is very difficult. And here's why. How do you evaluate whether a computer program does well? In the platformer game, it would just be the distance that the agent got in the game, for example. That would be its fitness or its score. In genetic programming, the issue is that the thing you're trying to evolve is a computer program. So the environment that you're evaluating the individual on, it could be a platformer game, but usually what we have is it's a programming problem. So it's just saying, I want a program that when I give it the number 2, it gives me true. When I give it the number 3, it gives me false. When I give you number 4, it gives me true. When I give you the number 5, it gives me false. And that program is like, it could be the even number program. So it's a program that you give it a number and it tells you whether that number is even or even or not. And all I know is that 2 is even, I know that 4 is even, I know that 6 is even, I know that 1 is not even, I know that 3 is not even, and I just give it like a million examples of this. And I say, okay, can you create for me a program that tells me if a number is even or not? And so what evolution would do is it would make a random program. Maybe this is the program that always outputs false for everything. Everything is false. You give it a 1, it'll say false. Correct, wow. You give it a 2, it'll say false. That's wrong. You give it a 3, it'll say false. True, wow. So it would be right on half of the cases just by outputting false all the time. Then you'd have another program that outputs true all the time, and it would be right on half the cases, right? And so then you have one agent that instead of it being true all the time is true all the time, but except for the number 7, it is false now. Just like by the program that it writes. Oh, would you look at that? It's slightly better now, right? You got 51% of the cases or not. And so it would slowly get better and better, and the programs would eventually, by the end of it, and we found this actually was pretty robust, would have a program at the end that computes the even number, that literally takes an input and computes. And there's this very important concept. I just submitted my thesis, and this thesis is all about this idea of generalization. So once you train the neural network, once you train the program, on, let's say, numbers from 1 to 1 million, I want it to work for any number, even if it's 2 million or 3 million, even if it's never seen that number before, right? And a computer program is very good at that, because if you actually find what it means to be an even number, like if it's divisible by 2, which you can check very easily on a computer, then it would work for every number, even if it's not been seen before in the examples, right? So in genetic programming, you have numbers from 1 to 200 are your inputs, and then your generalization test cases are between 1 and 1,000. So you train between 1 and 200, and then you test it on all the numbers from 1 and 1,000. And so we call a solution if it generalizes to all the 1,000 cases from the 200, which is pretty robust with genetic programming. And in machine learning, this isn't the case, actually. Machine learning struggles a lot with generalization because it's not finding the simplest explanation for the data often, which we can talk more about that if you're interested. But that's the main idea of genetic programming.
Yeah, that's phenomenal. You're talking about like a programming of the computer, and you're talking about simplifying it so that, okay, this happens here. And so if this happens here, can it be generalized across the board?
Exactly. So if my computer program that I know works at my house, like I want my laptop to work at my house, but I also want it to work everywhere on campus. But I can't go and test every single spot on campus that it works. I can test most spots, then I can say, okay, so it works in all these spots, so it's probably going to work on all of them, which is what you want in a computer program. You want it to work on all input cases and all output cases. It's hard. It's a really hard problem, because how can you ever be sure that it's going to work on something you haven't seen before? Like if you're building a neural network or a computer program that can tell you if an image has a cat or a dog, it could be right on most images of cats, but if you show it one image of a really fluffy cat that it's never seen before, it'll get it wrong, and then it didn't really capture what a cat actually is. Whereas if you ask a human baby or a human child, I guess, you ask a human child, they would very easily know what a cat versus a dog is, even if you show them 10 examples or 15 examples. Whereas with these neural networks and programs, you would need to show them millions of examples for them to learn what it means to be a cat. So that's one big difference between psychology and these AI systems, basically.
Yeah, I mean, it doesn't even sound like there's that much of a difference. You're talking about maybe a foundation that can be expressed in an abstract scenario and actually compute this abstract scenario in a proper manner. And this foundation could also be thought of as like reprogramming the self to think properly and to have these thoughts properly, so that when we enter any scenario that you're talking about, maybe like the cat, and you have a fluffy cat versus a hairless cat, and then you have this hairless cat, this does not look like a cat, but the foundation, when it's right, it's like, okay, both of these things are cats. And so when we have the right thought process, when we experience maybe failure or we experience maybe success, we don't actually, like, there's a poem called "If" by Rudyard Kipling, and it says if we could treat triumph and failure just the same, and that's the same idea. Is like, okay, I experienced failure, okay, I experienced success. I'm the same outputs happening from my foundation because my foundation is one strong and one actually is implemented. Because a lot of the time in the mental states and the mental programming that we have and we're walking around, there actually is no foundational implementation where our thoughts are just kind of all over the place. And the way it sounds from what you're talking about, this generalization would never be possible if the thoughts were all over the place or the programming was all over the place.
Yeah, I think you're putting on a really interesting philosophical note here, is that like humans also don't generalize all the time. You know, like you sometimes would fail at solving a problem and you instantly learn how to solve that problem like after that. So for example, you put your hand on a fire by accident and then now you know forever you're never going to do that ever again, right? You're never going to touch a fire ever again. You did it once and you learned and like really quickly rewired your brain to never do that again. And so you basically generalized to your aspect of what is dangerous. You now have expanded that field to including fire as well. And so you can imagine that's actually very similar to learning in these like computers, is like they do this thing called trial and error learning, where you basically just try things and then you learn from those trials. The thing is that humans are way more efficient than computers at this. There's something about human psychology that makes you really, really good at reprogramming, your brain. So usually in light of traumatic events or other situations like that, you have like really, really quick brain rewiring and neuroplasticity due to those events, and you learn very quickly. So if this is like not that traumatic, but you touch a fire on your hand, you're now in pain, and your brain reminds you never to do that ever again. Every time you see the fire, you remember not to do that. So like I had food poisoning a few weeks ago where I ate some popcorn, and I assumed the popcorn is what gave me food poisoning, but it could have been something else that I ate. But now anytime that I see that brand of popcorn, I instantly get like my whole body I feel sick just looking at it. And that's just my brain. That's like your brain saying, well, don't ever do that again. That's really bad. And I learned that from one example, But these neural networks, the training data, for ChatGPT was the entire internet. And for other big image models and other models like that, their training data is super, super, super big, way bigger than humans need. And so there's this really big tension between humans are super efficient and how can they be so efficient at learning from, events and experiences versus these models that are not very efficient. And I have some hypotheses about this, like some thoughts that I have, but obviously I don't have any experiments to back up the thoughts. But this is hopefully what I'll work on during the PhD.
The one thing I'm thinking about when you talk about this is distractions. Okay, so in this world in particular, like 150 years ago, the amount of distractions to now has been absolutely amplified beyond belief. So when you tell me about the popcorn event, which is hilarious because I know how that feels. You know what I mean? I've been through that before.
Yeah, I'm sure.
And now with the distractions though, do you think it's possible that our mind actually forgets about that event and we go and experience this event again? So it's kind of like a loop of us forgetting, or does the distractions not have anything to do with that?
That's interesting. When you say distractions, you mean things like social media and all these like other addictive online and otherwise things that are happening nowadays, like that are monopolizing our attention?
That, and also even the billboards. I mean, you go in the highway, you got like 50 billboards subconsciously. I really don't really notice it, but then when I'm really driving on the same road for the 100th time, I'm seeing, holy crap, these are all billboards that have been sitting into my mind.
Yeah, I mean, I don't know. I think obviously I don't have any psychology background in terms of experience, and I think it would be interesting to look at whether distractions like billboards that are like subconsciously there, whether they are if they're imprinting on your mind in any way. Like right now, are you aware of all the ads that you saw driving here? And if so, does that change your perception of the company so that you're like, oh, I remember that company? And so like I remember once I was thinking, I saw an ad for UMass, like the school, and I was thinking to myself, why would they advertise it? Everyone has to know about like the flagship university in Massachusetts. Like why are they advertising it? And then I was thinking, oh, what if it's just for subconscious like recognitions that you always like in your mind you're thinking about UMass, and so you always have that in the back of your mind. All these companies that advertise, especially even if you know about the company already, what's the point of them advertising? Well, it's because it'll help build the recognition that you have. So I'm sure there's a big industry here because of how much money there is in this field. So I'm sure people have done this research to see that. But in terms of rewiring your mind, I think that there is a very big, and again, I'm not a psychologist, so I don't know this, but there's a lot of research, at least on traumatic events and rewiring your mind. So there's your brain, rightfully so, when you have something traumatic happen to you, rewires your mind in a very, very tight way and very, very quickly, like with one trial. And that helps you it helps you in like the survival situation to avoid that event again, like because now you're traumatized from this event. But a problem with that is that it could lead in the modern world to things like PTSD, where now you're just like unable to do things that are relevantly, like, for example, if something really bad to you happens at a certain spot, you can never revisit that spot because it just triggers all these emotions, which it's like a correct learning thing that your brain created through evolution, or the evolution created in your brain. It's like survival advantage, but in this modern world, it seems to have a lot of downsides as well in like just learning in general and people having traumatic memories.
Yeah, that's heavily connected with fear and
Yeah.
worrying. And this fear and worrying goes all the way back to when the caveman comes out of the cave and you got the saber-toothed tiger coming and chasing him, and he's got to go find a hiding spot. And then the moment he finds a hiding spot and it's all good to go, it's all good to go.
Yeah.
But now we have like 12 different saber-toothed tigers coming at us from multiple different angles and all these different ways. And what I think is interesting is you made that connection with the computer science, right? How the coding is much more difficult, or maybe the human brain is much more efficient at recognizing this. I put the hand on the fire, and now I shouldn't do that again. And the coding is much less efficient than that, and maybe that is because of the distractions that are available to it, because it's pulling from the whole internet, like you said. And so, what do you think?
I mean, that's an interesting perspective there. I think that the way that you learn from the internet, okay, so these models that are these machine learning models are able to see way more data, but I think they care about each thing less than we do. So for example, they see 10 million images, and so they see, if there's one image that's wrong, it just kind of ignores it completely. And I think that humans are actually different in that sense, is that although we don't have 10,000 images, we have 100 images. And if one of them is wrong, we pay a lot of attention to that one. We're like, this is kind of surprising, this result here. Why is that? And I put more effort into that one. Whereas the machine learning models, just because of how they're programmed, they have to treat everything equally in how they look at the data. So every data point is just one data point, and they average over all of them. Whereas humans don't average at all. We pay attention to everything specifically. So an example of this is that if you want to train a model to learn what an apple looks like, you show it 1,000 images of apples and you say, this is an apple, this is an apple, this is an apple. And you maybe show it 1,000 images of oranges and say, this is an orange, this is an orange, this is an orange. And eventually it gets the gist. And it's like, okay, so red things are apples and orange things are orange, right? Like just something like that. But then if you show it an apple that's green, like a Granny Smith or whatever, it's now not going to know what that is because it relied on the heuristic of, red things are apples. And then if you show it Du Bois library, which is red, it'll say, that's an apple, right? When it's not, it's a library. So the idea is that when you show it this data, it treats everything with examples, and it doesn't pay attention to the counterfactuals or the really important data that might not be there. So an example is like a green apple, right? A green apple is still an apple. And so if you include one image of a green apple in the data set, it's not going to pay any special attention to the green apple. Whereas a baby or a human child would look at the red apples and then they'd look at the one image of the green apple and say, there's also a different kind of apple that's green, even if they just saw just one data point. Whereas these other AI systems would average over all of them, and that results in a lot of issues. So I think in this idea of like forgetting, I think they are just fundamentally different learning mechanisms. One of them is learning from data and a lot of data, whereas humans are learning from an experience, from a relationship with the world that they're in, right? And this is the tension between machine learning and this other field that I work in a lot called reinforcement learning, which is it changes how you think about learning. So machine learning, you have data with input and output pairs. So you say on this input, you output this output, and that explains things like ChatGPT up to the RLHF level, but we don't have to talk about that. But the idea is that these big models are trained to predict the next token from the internet. So that you show them a sentence from the internet, and then you say, what is the correct next word in this sentence? Then you train it for hundreds of thousands of hours on computers that are super expensive, and then eventually you get something that can predict the next word pretty well. And then now that it can predict the next word pretty well, you feed the whole sentence back in the model, and then it outputs the word after that pretty well. And then outputs the word after that. And then you do it again, you get a sentence that's outputted. And then you can get it to output words. Now the problem is humans don't learn that way. You don't teach a child to talk by showing them a sentence, covering one word and saying, what word goes here? What word goes here? You don't do that, right? That's not how it works. We learn by talking and by making mistakes and then by having someone correct us and then understanding, why was that wrong? But what I did was right, and learning rules and learning the structure. So there's a very big difference between them. Reinforcement learning is this other field that's in both psychology and in machine learning. It was actually invented here at UMass by Andy Bartu and Rich Sutton, mostly. I shouldn't say invented. They did a lot of work in it, seminal work, and they just won the Turing Award for it this year. Reinforcement learning is the idea of taking a reward function, something that tells you how good you're doing in the world and trying to maximize that by experience with an environment. So you have an agent that lives in an environment and it gets a reward signal back. So maybe it's like dopamine or something like that. And then as the agent acts in the world, it remembers what things gave it high reward and what things were bad and gave punishment for. And then it would repeat the things that gave it high reward and not do the things that it would be punished for. And this is actually very, very similar to the first game I was talking about, the little platformer game, is that you just give the agent reward for going further to the right. And so it would learn by reinforcement learning to continually get further and further to the right. And so reinforcement learning is this whole field of AI that's talking about solving these kinds of problems using machine learning techniques.
Okay, so from what you're telling me, it sounds like AI, first of all, should be used as a tool and not a replacement of human beings. And it's a combination of the usage of both together that's going to make it all better.
Yep.
And then to come back into the conversation that we were having before about the opportunity and why you even got here, that opportunity, if you were to have, and out of curiosity, if you were to have this system of AI where it didn't care as much about whether it's right or wrong. So you saw red apple, green apple. It's going to automatically be like, yeah, it's not an apple. Instead of like even think about it, say, is it really an apple? Is it not? So that right there, that doesn't happen in AI, but it does happen in the human being.
Yeah.
If you had not made your decision, which you obviously have, you've made a decision a long time ago to become the person you are and to go on this track, and you're still going to become a great person far beyond what's right now.
We'll see.
It's definitely true. But if you had the same thought process, you probably would have been less driven to forge out your life, you know, the way you're forging it. And so because when you said, no, I care about this is what I want, you know, instead of that more lax and saying, okay, this boom, 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 boom.
Yeah, I think that's actually very interesting. So I think what you're talking about, and correct me if I'm wrong, is that you're talking about this like goal directedness, like how I have goals in life and I do things to help myself achieve those goals. And I filter down the world and I pay attention to things that help me achieve my goals, right? And that's something that AI doesn't have right now. And like these AI systems don't necessarily have goals. I mean, the reinforcement learning ones do, and there is a whole field on goal conditioned reinforcement learning where they learn to set goals and actually achieve them. And I'm actually working in this area called autotelic reinforcement learning. Auto means self and telic means goal setting. So it means like self goal setting. The idea is that humans at least do this very well, is that it's like an open world. I can do literally anything I want right now, right? You know, relatively feasible. So I can do almost everything that I want, right? And so why do I choose to do the things that I'm doing? Like, why did I choose to come here this morning? Why did I choose to eat breakfast this morning? I just chose to do those because they align with some future goal that I have that I created myself. And it seems like right now, these AI systems, they're trained by people. So they have a data set. So these are the old-fashioned machine learning, not reinforcement learning necessarily yet. But they're trained by people and they have one task. Their task is to tell me whether this is an apple or not. And they don't have any goal. They're not incentivized to do that. They're just a model that just does that, right? When it starts to get a bit shady or gray areas when you get to these agentic systems, which are this new wave now where you give an agent you give one of these things, not just a thing saying, is this an apple or an orange? You now give it a body. You give it the ability to act on the world. So an example of this is like ChatGPT even has this now, and Gemini has this, and Claude has this, where you can take a model and you can ask it to do things for you. Like, hey, can you send me an email with this data? Or can you add this to my calendar? Can you do this? Can you go search the web for this and then compile the results? Like, that's it acting on the world, right? And so this is where it starts to get a bit like, I'm not sure anymore. Maybe you can imagine that it is setting a goal where it does whatever the user asks it to do. And this is the way they get it is by using this thing called reinforcement learning from human feedback, where they actually train the models after they do this next token prediction. They train them to abide by what humans want. And they train them to align to the human reward function, which is to help me the most in what I want to do. There's a whole can of worms here that I could talk about if you're interested. But the main idea is that reinforcement learning is about learning from an environment. And humans do this, and it's inspired by how humans learn. And it gets closer to that than machine learning does. Machine learning is just taking data, input, output, and then training a model that does that, right? So I think the really cool stuff is going to happen at least in the next few years in the reinforcement learning area. And that's where you can get beyond this, towards this goal setting idea.
And so what benefit is there in the goal setting of the AI? Because what we talked about was maybe the tool with the human. Yeah. But then if we're giving it the human aspect of goal setting, so what goes on there
Yeah, there's a really big moral question now, right? It's like, at what point are we just making this thing too intelligent to what we need? But so the point of AI as a tool, that's a very obvious win, I think. Like having AI as a thing that helps you solve problems, I think that's positive in the world. Like having doctors have assistants that are all AI that just like, they give them data and then the AI gives them like, oh, it's likely it's this kind of thing. Like helping people in decision-making systems, helping people with tasks, like they're just going to be like calculators plus, you know, in that sense. Now, obviously, there's going to be a lot of, just them being used as tools, I think there's going to be a lot of repercussions in terms of the job market and things like that. Like a lot of engineers will be, you know, the engineering positions will have less demand because you can have these systems that help you with engineering. But I think as a tool, I think it's very good. And when I say good, I'm talking from like a moral perspective. Like I don't think there's any harm coming from these things being tools. The issue is where it starts coming in is when they are their own agents and they have their own goals. And this is like it's pretty morally questionable. Is about like why would you give an AI the ability to set its own goals and actually accomplish things? And so the answer is I don't really want to build agents that have personalities and have wants and needs, for example, but I do want to build really good robots. And working in the real world, it's very hard to do if you don't have goals or reward functions. Because if I am a robot, so for the Apple example, right, I can give this agent a picture of an apple and it outputs one word, apple or orange. That's all it does. Whereas an agent, you have to give it the world and then it has to output what it's doing, right? But there is no right answer about what it's doing. Right? Like you can't say the first thing you should do is apply this motor torque on your right knee and apply this motor torque on your left knee and then you stand up. Like you have no idea. All you can accomplish, all you can do to assess these agents is by looking at their outcome, by looking at what they did and then assessing them based on their outcome. But the problem is that means that now they have a goal, which is to accomplish that outcome. And so you're kind of trapped in this issue where if you want to do robotics, it seems like you need to do reinforcement learning. And to do reinforcement learning, you need to have a reward function, which is a goal for the agent to have. Now, I think where it starts to get questionable is when, as I said before, is when you're talking about agents that are setting their own goals and have their own wants and needs. And that's where it starts to get kind of philosophical and kind of questionable morality is like this agent now might want to take over the world or might want to get rid of humanity, for example. And that's kind of a question, okay, that seems like a problem. So that really facilitates we need a lot of AI safety research here in the next few years for sure.
Yeah, so there's a lot of esoteric philosophy that talks about how we can do whatever we want, and we're in an open world where we can make any choices that we want.
Yeah.
And so you're basically describing maybe a recreation of that. Mm-hmm. And it is true when you say there is no right or wrong when you're in that scenario, and maybe there's no right or wrong in this world here as we live, and in the psychological world, in the mental world, and the way you're talking about programming and the way you're talking about how we got to set up the computer is very similar to how we have to set up our mind and our mental states and how we have to think. The other day, you showed me a phenomenal video. It's animation versus addiction. I've watched it maybe 3 times. I have no problem dropping it in here. Yeah, it's
cool.
Phenomenal. I've sent it to like 3 people too, just because I was like, this is so cool, dude. You'd love this. But that video in general, it talks about how, you know, it doesn't talk at all, but it has like a stick figure and he's moving through a world that's clearly, he could do anything he wants, but there's just one little shining thing. And he starts to center his world on that, and it's like a center of the world. And then now it's created this whole like unbelievable, robust situation in his own mental state. Right. And then another stick figure comes out and says, look, you have to get control of your mental, and you have to get control, and let's reprogram real quick and see what actually matters, because it doesn't mean that doesn't matter. Let's the addiction of let's say drugs, let's say the drugs, okay, maybe they do matter, but let's get control of the mental state real quick, and let's get control of what's actually happening. And then once we're under control, we quickly come to the conclusion, okay, wait, these things matter much more than this. And then the time gets filled up. We only have, maximum 120 years here as human beings. And the time gets so filled up that we don't even have time to go and do the drugs over there. And that in itself is an interesting concept where it's going to open up into the AI, but in a sense of it can go all these different directions, almost infinity. But don't you think we can go into like an infinite directions? But the time is ticking. So when you made the decision when you were 12 to go into MIT, the time is ticking. So then you have, I think you're 23, almost 23. So at this point here, if you're going to redirect, it'd be pretty difficult. And through that reprogramming system, it'd take a lot of courage. So
Yeah, I think you're talking about a lot of really interesting stuff. So I'll talk about the addiction thing first. I think that's addiction is your brain working correctly, and when I say correctly, I mean through the lens of an evolving animal. Like when you're living in a forest before humanity developed, like your brain thinks that you're a caveman, like in that sense. So your brain, it makes sense that your brain is going to chase like short-term pleasure, for example, from food, and because you need that to survive, and that's like what you're directly rewarded for. And there's this big trade-off, right? Is like sometimes the long-term benefits are way higher than the short-term benefit, but your brain still goes to the short-term, right? So this is a big problem in reinforcement learning also, is how do you make sure that your agents are optimizing for long-term success instead of just short-term success? And there's a lot of ways to do this. A lot of them are based on this thing called discounting. Like you future rewards should be discounted at a certain percentage of current rewards. Like, do you want $1 today or $1 in 10 years? Well, probably I'd want it today, and the one in 10 years is worth like 90 cents to me, right? So it's worth less the further out you go. And it makes sense that that's the case because you want things right now, and interest rates or whatever make money worth more now than it is in the future. But so that's one idea. So the idea of addiction is that you're not balancing short-term versus long-term rewards correctly, and your brain gets reinforced in this loop of, you have a trigger, and then you learn that whenever I have this trigger, like feeling sad, I decide that I want to go eat some food, and that trigger reinforces the food, and the food gives you some dopamine, and then now whenever you're sad, you go eat some food because you remembered last time that you were sad, you ate some food and it made you better, and then you get in this loop. And that's your brain working correctly. Like that's how learning works, is that you do things, you see how they help you, and then you do the things that help you more, and your brain thinks that eating food is good, so of course it's going to reinforce that. So instead of it saying like, oh, addiction is like a disease or something like that, it's not. It's your brain literally doing what it's meant to do. And now the problem is nowadays people are really taking advantage of that and using it to help. There's like psychology and how you can get people addicted to like your social media platform, and like just the likes. It's like the way that they engineer it, and the colors, and the way that the notifications come up. It's all to trigger the same kind of things to get you addicted in this loop. And that means that you're going to stop caring that much about the future, right? You're going to start paying more attention to the current rewards, like, oh, it's really fun to go on Instagram Reels right now for 25 minutes instead of doing this work, or instead of doing this workout, or instead of doing this other thing that doesn't give me that much dopamine right now, but does in the future. So there's a lot of really cool things there about that I learned about from learning about reinforcement learning that applies to real life too.
The addiction thing that you just talked about is very interesting. And it kind of falls into this reprogramming idea of the mental states in general, because you take somebody like yourself, very successful, you're going to the PhD program at MIT, very successful person. I can't wait to see what you do. But either way, you had to have become at least a little addicted to the process, no?
I mean, all right, so they call it workaholism for a reason, right? It's because the same exact thing is you derive pleasure from things that you give attention to. And so if you enjoy working towards a goal like that, you can actually like almost hijack your brain to getting that being the thing that gives you the dopamine, right? And there's this whole thing, I think Andrew Huberman talks a lot about this idea of if you're doing something challenging, like something that's mentally difficult, and you remind yourself that you're doing this, you can actually get yourself to release dopamine in the same way as if you were doing something like eating food, for example. You could actually get the same kind of dopamine release from that. So a lot of times people actually get addicted to working because they find it like it gives them some dopamine. And people get addicted to working out. People get addicted to all these things that are positive, So that, again, that's what I'm saying. Like addiction doesn't necessarily have to be this like your brain not working. It's your brain working, and you can do it in positive ways and negative ways. Obviously, workaholism is a difficult thing because there's diminishing returns. And I learned this difficultly in the first few years of work, is that you can put in 90-hour weeks and get really good results, or you can put in 40-hour weeks and get pretty much the same results minus 1% or minus 2%, right? So and there's this whole principle called the Pareto principle of the 80-20 principle, where you put in 80% of your work for 20% of your results, and you put in 20% of your work for 80% of the results. So 20% of the work that you do is like, for example, for the gym, it's just like going to the gym for 25 minutes. That gets you 80% of the gym results. And then to squeeze out that last 20%, you have to put in way more work. You have to start like tracking your macros and going to the gym for 3 hours a day and buying all these extra accessories and all this stuff just to get a tiny bit more good, right? And so there's this diminishing return of the more work you put in, the less work you get out per hour you work, right? So the first thing I learned is that, okay, so I have to enjoy work, which I do, and then I have to put a limit on it. And I think that having other things going on is a really good way to do that. So like having hobbies and other things and friends and all these other things that are going on in your head keeps you balanced and keeps you level-headed. So I'll say that at first I was working very hard and I enjoyed it a lot, but then I realized that even that could have been like a problematic addiction where I was like spending too much time doing that and I was not getting as much results as I could in general in life and in happiness and all these other areas that are important to me.
So do you think that 80% in that analogy there,
Yeah.
do you think that 80% is enough, or do you think that 20% is going to get you right where you need to be?
Yeah, so I think it depends on your goals. I think, at least for my goals, which is research is a very collaborative thing. Research is very social. It turns out it's not just sitting in your room by yourself. It is like that most of the time, but a lot of it is social and talking about ideas and communicating. And a lot of my success has come from talking to other people, my mentors and people that have helped me out throughout the way. I've learned from them, my friends, I've learned so much from them. And that the idea is that I learned from people how to be a social person, and that is important. If I were to spend all my time working on research, for example, by myself, that's me maxing out that thing. Maybe I'd get 95%, right, instead of 80%. But the problem is I'd lose so much more in all the other aspects of my life. So if you imagine, let's say I have like 100 soldiers, right? And you have like 5 different wars that you're fighting. And your goal is to how you allocate your soldiers to maximize your winning across all these different wars. So it's like I have one war, which is my research, right? So if I put 20% of my effort towards that, I get 80% of the results on that. Awesome. Next war is my health, right? If I put 20% of my effort on that, I get 80% of the results on that. Wonderful. Now I'm 80% good on research, 80% good on health. And then social, like if I'm like spending 20% hanging out with all my friends and being really happy, enjoying, I'm like 80% maximizing my happiness and my social time and all that stuff, the anti-loneliness time. And then other things, right? So I have, because I'm only putting in 20% for each of these things, I get 80% times however many of the things I do. But if I put 95% of my time into research, I'd only have 5% left to allocate to the rest of the things. And all in all, the output will be less. I'll actually be, which is kind of counterintuitive, right? So if you put all your work into research or all your work into your work or into your job, and then you now have like, you're not getting you're getting diminishing returns in that. And then you're also not getting the other stuff because you're not putting your time in there. So you're going to burn out and all these other bad things will happen. So the idea is to always be in moderation, everything, even the good things and the bad things, everything in moderation. And and that helps you maximize your life. You know, it's like trying to maximize the amount of experiences you have in life that are positive. And whether that be with your friends, whether that be during work, whether that be getting awards, all this other stuff is like, they all count, you know, they're all important. And there's no way that you can say that one is more important than the other. You know, you have to define that yourself.
So what challenges have you faced trying to implement this into your life? Because it sounds like you weren't as social as you were before from what you were saying.
Yeah.
It sounds like you might have not actually had this pat down. So what challenges have you had, and are you still working on it?
Yeah, of course. I mean, you know, life is a work in progress. I don't think anyone's ever done. So I, you know, starting in college had a lot of work because I was really interested in this stuff, and it didn't really feel like work. It was like more like fun. So I would be working on it. I would like to read. I would like to hang out with my friends. You know, I'm in college, so I'd like to have the college experience and everything. And so, yeah, I did struggle at first to balance everything, and it caused me a lot of stress, and it caused me to, start to isolate myself more. I was like, okay, so what do I have to do or else I'm going to get in trouble? Oh, I have to do my work or else I'm going to get in trouble. But I don't have to hang out with my friends because nobody's going to yell at me for that. And I was like, no, you know, like that's not how it works. I shouldn't just let the amount of punishment I'll get for not doing the thing dictate what I do in my day. So I started being a bit more ruthless about it, and started like really ruthlessly allocating my time. I was like, all right, what are the most important things for me is like these 4 things I mentioned. So I'm going to do those first, and then nothing else will get in my way unless those 4 things are done first. And that includes things like taking time off. You know, like if I have a day off scheduled, you know, it's very, very hard to get me to do something on that day if I say, but you know, to be honest, I have made exceptions all the time. Like if something comes up, I'm like, oh, I really have to do this, and Sunday I have nothing planned, I should do it on Sunday. And you know, and I do. And sometimes it's hard to stick to these rules. What I'm describing is like my ideal world, obviously, but again, it's a work in progress. So I'm identifying where I'd like to be, and I've been trying to work towards that throughout the few years, and I've gotten better, you know, and I've made a lot of improvements, and I'm grateful for everyone that's helped me get there.
Yeah, and either way, when you look you up, when you look yourself up, you obviously have made impacts and successes that are not common. It's not a common thing for an undergrad to go ahead and do what you've done. And clearly you have had that drive of, okay, this is happening regardless. It doesn't matter. This is what's going on. And I think a lot of people actually struggle with that. And I think it might be the programming of the mind. I mean, I think that you and I probably were one of the last generations that didn't really have the phone in elementary school,
right.
or maybe even in middle school.
Yeah.
And now that we're dealing with all of that, and I'm sure there's even people that are going to be that age, maybe even seeing this and being very interested in and in awe by you and inspired. But either way, that right there is very interesting, because I feel like people are kind of losing that drive of, okay, this is what it is and this is how it's going.
Yeah.
Now, did you ever not have that drive? Like,
oh, of course. I mean, me in high school, I wasn't always super driven and motivated. Like, I had a pretty fun high school. I played a lot of video games, hung out with a lot of friends. Like, I did a relatively normal thing, and I did a lot of stuff. Like, I was on my phone a lot, and I was on these social media platforms a lot. And of course, I was a human, and I think everybody here, there's an issue nowadays, I think, partly with the podcasting community and all these people that are on this like self-improvement kick, is that they make themselves look perfect, and they make their life look perfect. Like, I eat exactly what I'm meant to eat every day, and I do all this work every day, and I'm this productive every single day. But like, you're not watching their real life. You're watching their highlight reel. You're watching the thing that they chose to show you. So when you see videos like this and like other things, don't ever compare yourself to them, because what you're comparing yourself to is you're comparing the person that you are versus the person that they're showing you, which is not who they really are, and it's not really how they live their life. And what the problem is that a lot of people let being perfect get in the way of being good. And so you're like, if I'm not going to be perfect like David Goggins and run 100 miles every week, then I'm not going to do it at all, right? And I'm like, no, running 1 mile a week is 1 mile better than running nothing at all. So if you don't have to say, if you're not going to run 100, I'm going to run none. You should say, okay, I'm not going to run 100. That's unreasonable, but I'll do 1, I'll do 2. And then eventually you'll start building your way up, right? And so all these people that are talking about how cool they are and how much work they do and all this stuff, they're lying. And if you try to achieve that, you're going to realize that's not possible. And then you are not going to get anything done at all, because you're going to realize you're going to think you're a failure. You're going to think that you're worse than them, but you're not worse than them. You're the same as them. You might be even better than them. It's just that they're showing you the best parts of their life. So anyways, yeah. So my advice, if you were like in the younger generation and you're saying, you hear all these people say that, oh, you guys are not doing anything, is like, figure out what you enjoy and do that. Figure out what you enjoy, and the money will come later. The fame or whatever you want would come later. And if what you enjoy is something like, oh, you like to spend time a lot on social media, you can think to yourself, okay, is there a way I can make this productive? And is there a way I can make this productive? Things like social media is a bit harder. Things like TikTok is a bit harder to make that productive, but you could start making TikTok videos and start like getting brand deals and things like that. You could. There's a lot of ways to work around it. So you have to kind of figure out what things make you passionate outside of like short-term dopamine gains. Like 10 years from now, what do you want your life to look like? And then what's the kind of person you want to be? And then just live your life as if you're that person already right now. So, it's easier said than done, of course, but just think to yourself, okay, I want 10 years from now, I want to be happy. I want to have a group of friends that I can rely on. I want to be healthy. I want to be, have X research qualifications, blah, blah. I want to be in this PhD program. And you just imagine, if I was that person today, what would I do right now? Would I go on my phone for 25 minutes and then get out of the house, or would I go to the house right now? It seems like that's a really easy way to make a decision. But again, as I said, all of this is with the 2 cents of you shouldn't be stressed about doing that, because if one day you don't feel like it, you should just not do it. You shouldn't feel like you always have to be on top of your game, because by doing that, you're not going to get started at all. So there's this book I read called Meditations for Mortals, and another one called 4,000 Weeks, both by Oliver Burkeman. Really recommend these books for people that are getting started and are into knowledge work, like doing school, about to start school. If you're like 18 or 19 right now, it's a great time to read those books. The idea is that your life is going to be around 4,000 weeks long, like just 4,000 weeks, which is saying that makes it seem really, really short. That it's not that many weeks, that's a small number. And so you have to really spend your time in a way that you think is reasonable. And so if you get to be the best in your field and the best person in the world, at the end of the day, what is your life about? Is it like you sitting by yourself all your life working hard? And is that really what you want? And so one thing that he says is, I know a lot of people that are like this, and I personally was like this too, is that I have all these systems. Like I have note-taking apps and I have all these things. I say, okay, I'm going to read a book and I'm going to take notes of everything I think about. Then after I'm done reading the book, I'm going to write it up in a summary, and I'm going to write it into my Obsidian notebook, and I'm going to make sure it's there, and then I'm going to link it to other books that I've read. And then I realized, I was like, I just didn't want to read anymore, because now I just made reading 3 times as hard. I just made it that now if I want to read, I also have to take notes, and I also have to write it up, and I also have to think about it. And so I just didn't read at all. And so that was me making perfect the enemy of good. I was saying, if I can't be perfect by doing all these things I need to do, then I'm just not going to do it at all, which is way worse, right? It's better to just read and just let what sticks stick instead of having to take notes about everything. So he talks about a lot of these things, and I thank him for a lot of these kind of insights that I've had recently and over the last few years about, taking your foot off the gas actually might make you go faster in the long run.
Yeah, that's genius. And there's also another, it's genius. There's another idea that actually fits in here quite nice, is that our senses, our 5 physical senses, only pick up approximately 1% of what's actually going on in the world. But our interactions are having 100% impact.
Yeah.
So, for example, I had an experience with a gentleman, and we talked, and I didn't think it was much of it. But then I hear from somebody else that the guy's talking so highly and so phenomenal about the words he's saying are just so phenomenal about me.
Yeah.
And I was like, holy crap! Like, I did not think for 2 seconds that interaction had stuck in his mind past the minute that we walked away from each other. And I think that goes perfect with the running you're talking about. That 1 mile, you might that 1 mile that I run might impact everybody that drove by me and said, wow, like maybe I should be running. Yeah. Maybe I should be doing, and then the ripple effect, like when you throw a stone in a still pond, like that is a real thing. Yeah. And the other 99% of the stuff that we're not noticing here is just being impacted, but we just don't know.
Yeah, I think there's this really cool idea is that I forget whose poem this was. It was a really cool poem. It was like talking about a group of friends where one of the friends passed away, and then they were talking about how although the friend is gone, what isn't gone is the part of that friend in one of the person, and then the part of the friend in the other person, and the part of the friend in the third person. Like they live on in the friends that they had, and then not only that, but they also have the part of the friend that's in the part of the friend that's in my friend, like through people. Like my conception of Greg's conception of my friend is like another conception of my friend, so you can think like you live on in so many different spaces than you even exist. I think that's a very powerful idea, and I think that kind of shows like you should be like a personality. You should be someone that's interesting and someone that has a lot going for you besides just like one monolithic thing that you've accomplished. You should be trying to be a whole person. And I think that I've come to a lot of conclusions about attention recently, and you were talking about this before, is like I have so much data being fed to all my senses right now, but all of my attention is to this conversation right now. Like there could be stuff going on in the background and sounds and all this stuff, and I'm not paying attention to that. I'm paying attention to talking. And it's interesting that I can pick that. I can choose what to pay attention to, and that is a filter on the things that happen in my day. And that's actually very relevant to what we were talking about at the beginning, is what you pay attention to are the things that kind of happen in your life. And so if you're always constantly paying attention to your phone or to negative thoughts in your head or to feelings of failure and all this stuff, that's the kind of energy, it kind of sounds like voodoo or whatever, but it's like the energy that you attract is that like negative energy. But if you instead are constantly thinking about positive ways, goals that you're achieving, your friends, and like being there for your friends, it like emanates that in ways that you don't even notice. And, you get more you pay more attention out and the world gives you more. So I think one thing that I've learned a lot about this idea is like mindfulness and paying attention to everything and being constantly in the moment and trying not to be lost in thought and trying not to be lost in thinking about something else when I'm here. Because like right now, there's a bunch of stuff happening in the world that I could be thinking about, but instead I'm thinking about this. And I think that's like the most intimate kind of like thing you can give someone is full attention and talking to them when you're talking to them.
Absolutely. And then it kind of goes into this idea that I really do want to talk about with you, as far as the computers, and then also reprogramming the mind to work properly and to function properly. It's this idea of compound interest, like the 8th wonder of the world there, compound interest. You give this full undivided attention. What is that compounding into? It turns into something that I'd like to hear what you have to say about it.
Yeah, I mean, I think it's interesting. So by me putting in this small amount of attention, you would feed back some attention back to me, and then I would feed more attention to you, and that would help me. It kind of like is this cycle where you improve and get better and better and better at this giving attention thing. So I think in the idea of compound interest is that the more attention I put out, the more good I notice in the world, and then that means the more attention I put out, and so the more good I notice, and so it's like this positive thing. Whereas instead you can get in a negative loop, and obviously this is from anecdotal. I don't know about this psychologically, for example, but you get in a negative loop where if you start paying attention to only the negative things, any sign of negativity, you start using that as, oh yeah, I'm right about negativity, so you become even more negative. So I think that positivity is compounding upwards and negativity compounds downwards, and you really want to be on the right side of that idea.
Right, and that's where the programming really matters.
Yeah.
Is that where that, to go back to your thesis and with a generalization, to be able to actually identify the generalization, is that you have to have the program to be foundational and actually in place and not moving, no moving parts.
Yeah.
We can't have these moving parts. And if these moving parts happen, I guess the compound interest kind of fades away.
Yeah, if you like flip flop, if you're positive sometimes, negative sometimes, you could imagine that doesn't really help you. But really, I think that people will change. Your brain will change in 1 year. You'll be a completely different person. So it's normal for your brain to change, but you have to be consistent, self-consistent right now. Like you can't think to yourself, okay, I'm a marathon runner. I was telling you before, just imagine you're accomplishing your goals. Let's say my goal is to be a marathon runner 10 years from now. So I think today I'm a marathon runner. So would a marathon runner do this? Would a marathon runner do this? And then if I suddenly then look at, eating a cheesecake from Cheesecake Factory, a marathon runner probably wouldn't eat the whole thing right there in one sitting. And so if I do it, that's kind of like me self-contradicting myself. I'm saying that, I'm putting a vote in to the person I want to be, and that vote is 1 to the marathon runner. And then now that I eat the cheesecake, that's like 5 votes to the not marathon runner. And so you're basically being inconsistent, and so you're wasting your time and wasting your energy in that sense, which is fine. There's no judgment here. Everyone does that. I do that all the time. It's just like that now you can identify, oh, okay, so this is what's wrong, is that I say I'm this person, but then I don't live up to the things that person would do. And so there's this idea also from James Clear, a guy that wrote Atomic Habits. He says that every habit that you have is a vote for the person that you want to be. So if you want to be a researcher like I do, then I have to do things that researchers would do, which is number 1, do research, and number 2, learn and read books and do all this stuff. And so every time I do that, I feel a bit of dopamine because I'm working towards a goal. I feel a bit of dopamine comes from pursuit of goals, not from actually achieving the goals. So I actually feel that pursuit. I feel that excitement from pursuing a goal, and I get a vote for being the person I want to be. So I know that when I do research, I'm voting for when I do I write a paper or read a paper. That's one tiny step towards being the person I want to be. And that's wonderful. And so also I want to be someone that's healthy. So every time I do something healthy, that's 1 vote to be the person that I want to be. Now it's not perfect. I don't always do healthy things, but your votes are votes. So you have to be democratic about it and have whichever majority is the thing that happens is likely the direction you'll be going in. So it's kind of wasting your time if you're voting constantly in both parties, right?
Yeah, absolutely. And the wasting your time when you talk about how it's okay, I love that point. I kind of want to highlight it because it is okay. It's okay to waste our time because I think sometimes we have to waste our time to figure out where we want to put our time.
Exactly. Yeah.
And it's that confusion that's going to maybe leads us to our goal, and then it kind of goes into the direction of ourselves. It's like, okay, you took this direction of I want to go into this research. I want to be a computer scientist and make this happen. Well, maybe the world had to shift in a way where you were confused for an X period of time, or you were frustrated for X period of time, or anything like that. And that would create this mental state that was actually necessary for a specific period of time in the future. And so that's where this future idea comes in. And you said that the social media or the way the likes are and the programming of the likes is actually bringing our focus to the present and rather than the future, and that's where the issue kind of lays. And then that focus on the future is where we won't be really wasting our time.
Yeah, there's a subtle contradiction in the things I've been saying right now, where I did say that the social media and stuff is not making you think about the future long-term consequences of your actions. But I think that actually, and then I also say we need to be mindful and be in the moment, right, and live in the moment and enjoy it. So there's kind of this weird dichotomy here. It's like, which one do you want? Do you want me to pay attention to the future or now? And I think it's a very, very difficult question. I think you have to be present and have to appreciate the current moment and not be lost in thought thinking about the future, because the future is just a thought. At the end of the day, the future is just a thought happening right now, and there's nothing. It doesn't exist. And your past actually also doesn't exist. It's just a memory that you have that's happening right now. So the only thing that's with you right now is this exact moment. So if you're spending all your time thinking about your future and thinking about your goals, you're not in this moment, and you're kind of like thinking about something that doesn't exist right now, right? So I think that you should, in setting goals, you should have goals and you should be able to pay attention to them, but you shouldn't make them the only thing you ever pay attention to. You should pay attention to the general moment, or else what's the point of living? If you're constantly living in the pursuit of something else, you're always going to be hoping that you're in a different place to where you are right now. And the only place you could ever be is right here, right now. And so why shouldn't you just like, isn't that amazing? Shouldn't you just be right here, right now? And you can take small steps today to help you become the person you want to be. But at the end of the day, you have to enjoy it right now, or else you're not going to do it. So you have to enjoy doing the research, and you do by saying that it aligns with your future. That gives you a bit of like energy and happiness today, which is the thing that you're looking for today. So the idea, at least my thesis that I'm putting forward, not my honors thesis, my thesis that I'm putting forward from this conversation is that you should be in the moment as much as possible. You should know what kind of person you want to be, but don't live in the future. Don't live like, oh, I can't wait until I have this. I can't wait until I have this. Like 5 years ago, you wanted what you have right now. So why don't you just enjoy the thing you have right now in the moment, And so the whole idea of this is to, instead of having many wants, instead of like having many wants and trying to accomplish them all, you should just want the things that you already have. And then when you do, you're happy right now. In almost everyone here, and if you're listening to this, and I'm assuming us here, I think there's probably billions of people on this planet that would give anything to swap places with you right now. Like no matter what you're going through, you can imagine that there's a billion people on this planet that would choose to switch places with you right now, right? And so that is like something that you have to be really grateful. I mean, I'm not telling you what you have to do, but I'm very grateful about that kind of idea, saying like, wow, I'm in a really, really wonderful place. And although I don't have all these goals achieved, and I don't have all these things that I have in my vision board, accomplished, like I am still very grateful to be here right now. And I'm not going to be constantly letting that go by hoping for something else. There's this meme I saw, which is like a guy in a motorcycle, and then there's a car next to him, and he's like, oh, I wish I had a car. And the guy in the car is like looking next to him, it's like a nicer car. He's like, oh, I wish I had that nicer car. The guy in the nicer car is, wishing that he had a like even nicer car or a limousine or something like that. And the guy in the limousine is like sad, and he hopes he's happy. He goes to the guy that's happy, that's on a bike. And the guy in the bike is like, oh, I wish I had a motorcycle. And then it's like a loop like that. So everybody wants to be someone else, and nobody's ever happy. And so what's the point of like working towards all these things and trying to be super, super successful, and when at the end of the day, all you're going to want is the thing that you had at the beginning? All right. And then last story is that there's this parable of like a fisherman and a businessman. And then the businessman goes to the fisherman and says, so what do you do every day? He says, I fish exactly as much as I need for the day. And then I cook the fish, eat it with my wife. And then we go into town and have some wine and celebrate and just like hang out every single day. And then I can listen to music. And then I go to sleep. Then I wake up and fish the next day for the fish for that day. And the businessman's like, oh, but like that's not very efficient. You could fish all day long, get a lot of fish, start a business, and then get super rich, and then incorporate your business, and then like make a fish business, hire other fishermen. And then the fisherman's like, then what? And he's like, well, then you can go and drink wine with your wife and go out to town. And he's like, but I'm already doing that, And I think that's the idea, is that you always, if you're trying to achieve these goals, at the end of the day, all that the goals are giving you is just more things to have to deal with. And then eventually you're going to get to a point where the real freedom is just not having those things in the first place. And then you had that at the beginning, So why'd you start this whole journey? So it's not to say to not be an entrepreneur. I think it's great, but just think about what you're doing.
I love that. The circle through with the motorcycle to the car, to the fancier car, to the limousine. That's just brilliant. And everything we talk about with programming the mind is to get somewhere. But I think to solidify your point with the future and to not necessarily be thinking too much in the future, it's like your computer science coupled with the psychology of reprogramming our mind in the way we want to. It's all about the ones and zeros. It's all about going back to the fundamentals and making sure our fundamentals are right. Because there's nothing more. Once our fundamentals are right, there's nothing more to master. Once I've mastered the fundamentals, that's it. And also, there's a saying that I don't think a lot of people have agreed with me. I've asked a lot of people, a lot of successful people, and it's very interesting because the way it's worded, maybe it's not. Yeah. But when your attitude is right, the facts don't count. Mm-hmm. I got that from a gentleman. I have to give him credit, Kevin Trudeau. This guy, Kevin Trudeau, he's a great guy. But yeah, when your attitude is right, the facts don't count. And so when you have the fisherman going through and doing the same thing that the businessman was saying, hey, do it over here. But it's I think about that all the time. It's like, wait, no, I have the food. I have the beautiful life, and it's a beautiful life. It's something that I would never want to give up in a million years. And I think we all, if we think about, okay, what's really so bad? There's nothing really so bad. It's the mental state that we're in at the moment. If it ever is thought to be bad.
Right.
So
yeah. I think I think you put it very well. Yeah, the idea of like when your attitude is right, the facts don't matter. I think that's a great quote. Like your perspective on the world and your attitude to how you take things, how you see things. It doesn't matter what's happening to you. If you're positive and you look at them positively, then that's how you're going to interact with them. Like it's like there's some stoicism quote about how you are like bad things happen, doesn't matter. It's how you react to them that counts. It's like how you actually what your attitude is when they happen that matters. And what's happening in your head basically. And that's the only thing you have control over from that passage, right? So I think it's very powerful.
Yeah, and to make sure we reprogram our mind in a way that we think properly is something that I think we've talked a lot about here, and I think we've hit a lot of different things. Ryan, this has been fantastic.
Yeah, thank you very much, Greg. It's been a pleasure.
Yeah, thank you. And maybe I get to see you again.
Yeah, hopefully.
But either way, I'll be in touch, and we'll talk soon. So,
yeah,
great. Yeah, that's awesome.
Yeah,
thank you so much for your energy. Thank you so much for your effort, your time, and your friendship. I appreciate it greatly. You're the man. I look forward to the next time that you and I can have a conversation. But in the meantime, everybody subscribe, comment, DM me. Talk to me about what has inspired you in this video. Talk to me about what's on your mind as far as being a better character, being a better you tomorrow. I am profoundly interested in this question, and I'm willing to learn from you who have learned from this video, because we all see things differently in life. And I think we all can come together and learn so much more when we do it as a team. Thank you so much. Till the next time.